Hello, thanks for watching this video. My name's Logan Dyer, and we're going to be going over the HPPD inhibitors, group 27 herbicides. So just a little background on the HPPD inhibitors. They are our newest mode of action, first being put on the market in 1980, but not actually understood what the specific site of action was. We knew they were pigment inhibitor, bleaching herbicides, but it wasn't until the late 90s, early 2000s, where they were finally put as carotenoid biosynthesis. And these herbicides have a broad spectrum of weed control, able to control both broadleaves grasses, pre and post-emergent. So some history on this mode of action. We actually found one of our chemistries through a bottle brush plant in Australia, where scientists found that there were no plants be able to survive around these. They were able to extract the actual herbicidal compound inside that plant, and then they were able to synthesize their own, and now we have mesotrione, sold under the trade name Callisto. And then sulfatrione was one of the early HPD inhibitors, and it was sold before they actually knew the mode of action. They actually thought it was a protox inhibitor, but later they found out it was the HPPD. Early on, when they decided that these weren't protox inhibitors, they thought that it was tyrosine hydroxylase. And this schematic kind of shows the processes that the HPPD inhibitors affect. So the carotenoid biosynthesis and the plastoquinone biosynthetic pathway are kind of intermingled, where their byproducts help the others' synthesis. And so what HPPD actually does is it goes in and interferes with this tyrosine byproduct, homogentisic acid, that then goes down and helps with the production of the plastoquinone 9 and also the carotenoids. So when you disrupt the homogentisic acid, you don't have any production of the plastoquinones or the carotenoids anymore. And so the way this actually kills the plant is a cumulative effect of 3 different processes. And so once you stop the production of a plastoquinone, there's no more energy, the plant stops growing. Without vitamin E being produced, there's nowhere for those free radicals that are always going to be produced from photosynthesis to have a way to come down to a lower state. And therefore, those free radicals are going to go and break through some of those cell membranes. And then we also have the inhibition of carotenoid biosynthesis, which is why we see the bleaching. And there's no protection against the light rays and UV rays that the plant usually has, and therefore all those 3 end up actually killing the plant. So the use of these HPPD inhibitors is pretty widespread on quite a lot of different cropping systems, but it's most commonly used in the Midwest for pre-emergent control of broadleaves and corn. And as I mentioned earlier, it can be used pre or post-emergent depending on the rates. And it also can be grass and broadleaf control depending on those rates. The GT27 trait has been inserted into soybeans for HPPD resistance to isoxaflutol. This is only for pre-emergent, and the herbicide that's labeled Alite 27 is not on the market yet. And the selectivity for these herbicides is going to be based on the rates and the speed of metabolism within the plant, so that corn can metabolize at a faster rate than the HPPD inhibitors can actually work in that plastoquinone and carotenoid biosynthetic pathways. So we do have a case of synergism. People commonly tank mix these with PS2 inhibitors, specifically atrazine. And I actually read in a paper that the best one was mesotrione with atrazine. And then antagonism was found to be with sulfonylurea and mesotrione. due to poor translocation. Environmental fate for these HPPD inhibitors as a group is pretty low risk herbicides. You have to remember that these are the last, some of the last herbicides to be discovered, so they're under the most scrutiny as far as regulatory aspect goes, and therefore they have low acute toxicity, they have low use rates, there's no volatility, no photodegradation for most of these, and then in almost all of the HPD inhibitors, they don't move through the soil profile. Isoxaflutol is kind of an outlier where you do have some movement in the soil profile depending on the soil textures. The soil half-life is only 13 days, and it gets metabolized in the soil. For resistance, we have 11 confirmed cases in the United States. Most are going to be found in our corn cropping systems. Also in our soybean and sorghum systems, we've found resistance. The big plant that we've found resistance to is the water hemp. It's dioecious. It's a broad genetic diversity. And then we found some palm amaranth that has been resistant in the south. There was actually some water hemp that was resistant to PS2 and HPPD due to tank mixing those, believing that there's synergism. When you have a atrazine-resistant water hemp plant, then you're just selecting for that HPPD resistance. So at this time, I'd like to thank you for watching the video. And if you have any questions, feel free to give me an email. Thank you.